Let's do unit circle lesson. For this one, make sure that you know what a special right triangle is and that we learned what a reference angle is. I'm going to be talking about that in a little bit. It's in your notes though, so if you want to stop the video, you can look at it then. All right, what the unit circle is just placing the special right triangles, the 30, 60, 90s, and the 45, 45, 90 on the coordinate plane. So let's take a look at what that looks like. Again, here's the angle that we're going to be talking about is 30 for this one, because we place 30 degrees up, and then you would form this kind of triangle. And please make sure you understand where these numbers come from in the prior lesson. And what we're trying to figure out is where these points are on the circle. And if we recall from our notes, I said that sine is dat y value and cosine is dat x value. And now I kind of just put that on the notes, but it should make sense now because when we look at this, x is how far off you go from the origin, and y is how up you go, and cosine is the adjacent side. So therefore, it should make sense that when we're talking about that, it would give us that length always. So that's why we referred to cosine as the x value, and then sine is opposite over hypotenuse. And by the way, hypotenuse is 1, so when you divide by 1, you literally just get the y value. And it gives us the y value, okay? And then the really exciting thing about calculus is that you get tangent is going to be very important later, and it tells you the slope. It's y over x. Very important later, okay? And we're going to fill out this table in a moment, but I also need to place the other values around the triangle. So if we take a look at the 45, 45, 90 triangle, you can see that it's an isosceles right triangle, so these are the same. So when I place this on here, you can see that it lines up perfectly right there, or pretty good. And if we fill in the same x value, or the xy values, I'm going to do it up here. You're going to get root 2 over 2, and again, it's isosceles, so it goes over and up the same amount, root 2 over 2. That's supposed to be root 2 over 2. And now this is the same, this would be 60 degrees right here, and that's going to be, by the way, you can see the numbers are flipped because I just flipped this graph, and you're going to see that this one goes right there, all right? I'm not going to place that one up there just for, it's hard to see. But what would happen is it would only go over 1/2, and it would go up root 3 over 2. Hopefully you can see that because it goes, long leg, short leg. So then the x coordinate would be 1/2 now. Oh, no. The y coordinate would be root 3 over 2. And by the way, if theta was 0, then it would be right here. And if theta was 90, it would be right here. So now let's fill out this sine values. So the sine of 0 is, how much does it go up? Because it's y, 0. How much does it go up when it's 30? 1/2. What you'll see with sine is that as theta grows, so does the y value until 90, and then it starts to shrink. And that should make sense because see how the y value goes up 0, goes up 1/2, goes up root 2 over 2 for the 45. Oh boy. And again, I'm getting that from this 45. It's the value of y is root 2 over 2. And then the y value is root 3 over 2, which is larger than root 2 over 2. If you don't believe me, you can use a calculator. And then at 90 degrees, it's straight up and down 1. And that should make sense because you see the point going up, and then once you go to past 90, you'll see the point going down, which should make sense. And then it goes back to 0. All right, cosine. So the cosine is the x value. So initially x is all at 1. And then cosine for the next one right here is root 3 over 2. And one thing that you should notice is that there is a pattern, and it's going to be in the reverse order. All right, for sake of time, I'm going to stop and just fill out in reverse order, but you can see that the x coordinates I'm getting from there. This would be 1/2, and then here it doesn't go over at all, 0. Oh boy. Now for tangent, it's just this divided by that. So 0 divided by 1 is 0. 1/2 divided by √3/2. People get scared when they see these fractions, but when you divide 1/2 by √3/2, what happens is it's nice. These denominators, the complex part of the fraction, disappears. So it's just 1 divided by √3. Now I would leave my answer as 1 divided by √3. It's just that we, as math teachers, we don't like this root dividing by an irrational number. So we rationalize it. Okay, so I'm going to write that because that's what I'm supposed to teach you, but they're the same thing to me. That's a 3. All right, again, you'll see tangent grow, and that should make sense because the angle starts off at 0. Remember, we're talking about slope, and the slope slowly rises to undefined. Again, when I think of tangent, I think of slope. Again, the 2's cancel out, and it's just something divided by itself, which is 1. And now we have √3/2. These cancel out, and you get √3. Starting to diverge, starting to grow, 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 grow. And finally, we get undefined, or error, because you're dividing by 0. And I'm just going to symbolize that with a frowny face. Okay, but that's straight up and down, and it should make sense. All right, so let's talk about a reference angle. Basically, what we're going to be doing is we're going to be taking these same angles, and we're going to be flipping them across the horizontal, and you will see that it fits in right here. Okay, so let's do that down here. Okay, so you see this guy I already put here. So the angle that you would be given would be, they'll say, theta of equals 120. And when theta equals 120, we get an angle that looks like that, and it's 120 degrees. Now, because Mr. C is amazing, he has taught you that a linear pair, which is an angle here and an angle here that forms a straight line, equals what? 180. Good job. So then this is going to be 60, as I've indicated here. Oh, wow. And we just fill out our table. Now, when I do these problems, I visualize the right triangle if it doesn't just pop into my head. And from here, you can see that this length would be 1/2. Again, short leg. Long leg is √3 times it. And so if I asked for the cosine of 120, cosine of 120 and the sine of 120, degrees, it's important that we use the reference angle of 60 for our special right triangle, because there is no special right triangle that's 120, just its reference angle, and then we can use that. And then it's the same lengths for this point. So the x coordinate is going to be 1/2, but there's something special about that. So this, it's in the second quadrant, and all the x values are negative, so it's going to be negative 1/2. Boop. And then the sine is going to be √3/2. Because it's dat y coordinate. And yep, and everything's just basically a variation of that. Notice that the y is positive, but if it was in this is the first, second, third quadrant, they'd both be negative, and then in the fourth quadrant, the x is positive and the y is also negative. Right? Let's take a look at some examples. All right, so I'll do the first one on here, and then I'll do these down below. And some people like to just fill this out right away. They'll memorize it. It's up to you. And some people like to memorize that table like I did, fill this out, and then everything just follows around with it. I just normally I'll show you how I do it, like on this one, or this one, or this one. How I like to do it. But again, there's many ways to do this. So cosine of 90. Again, we're saying that the angle is 90 degrees. So we're talking about this point, and x is that x coordinate, and it doesn't move off the origin, or it will move off the in the x direction, so it's gonna be 0. That's it. I mean, we also could have used the table, by the way. Again, cosine of 90 is 0. Beep. So you do any way you want. I like to visualize special right triangles. This one isn't a triangle, it's a straight line though. All right, pi over 4. Oh no, it's radians. Some people like to do pi over 4 and convert it to, that's supposed to be pi. And they like to convert it to, oh, sorry, that's supposed to be 4. And they like to convert it to radians by multiplying by 180. But I just know pi is 180, and I just need to half it twice. So half it once to get here, and half it again to get to 45. And or you do you. But this is basically the sine of 45, which they're both root 2 over 2. So, and if you wanted to, again, it's saying sine of 45 degrees. If you like the table, you just go over to the table and say, yeah, root 2 over 2. All right, 150. So we're going to have to go 150 degrees. Now I'm imagining these aren't here, by the way. But if I had this available, I would just look at it and go, yeah. But that means that the reference angle is 30. So I'm dealing with the 30, 60, 90. And I need to know the sine value. And sine is going to be 1/2. You can see that across from 30 is going to be 1/2, or just, and it's going to be 1/2. And then let's do tangent of 245. I think I wanted 225. Let's do 225. 225. All right. So this one, I'm glad I did that. I like how this one's in the third quadrant. When I do this theta, so my theta is now 225, and my reference angle is the angle that's formed right here. And I would do 225. So 225 minus 180, giving me 45 degrees. And that is going to give me this angle. And that's just the angle sum postulate from geometry. Basically, two angles. If you add theta is this big angle, and it's composed of the reference plus 180. So I just angle sum theorem. So this gives me 45 degrees, and I know that it wants me to do tangent. So tangent is not only the y and the x value. So the y value is going to be negative root 2 over 2, and the x is negative root 2 over 2. It's basically something divided by itself, which is just going to equal 1. And it's going to be positive 1 because it's a negative divided by a negative. Negative divided by a negative. All right. Cool. Those are some 4 examples. There in this video, I'm not covering, or in this lesson, I would have made you do more if we weren't in the circumstances we are. But if you'd like to do those ones, you can ask me how to do them. I think you're gonna have to do them in pre-calc, most of you next year, anyways. But I wanted to challenge you more, but during this time, I'm doing what I think is right. So please, if you want to challenge yourself, do those ones. Message me if you want to know how to do them. If you want me to make a video, I can. I'm just chilling. But let me know what you guys need or anything. All right. This concept is something that people struggle with. So if you need some love with some of this stuff, just let me know, and I'll help you. All right. Boomer out.